Have you ever seen a picture of the Northern Lights and just been completely mesmerized? They are, without a doubt, one of the most incredible sights on our planet. But what if I told you that beautiful, shimmering light show is actually a signpost? It's telling a story of a powerful, invisible process high up in our atmosphere. And hidden within those gorgeous lights is a powerful secret, a story of destruction. So let's dive in and uncover it. We know them as the Aurora Borealis in the north, the Aurora Australis in the south. These ribbons of light, they seem almost magical, don't they? They've captivated people for thousands of years, just dancing across those dark polar skies. But what exactly are we looking at? So at its heart, an aurora is just a beautiful collision. It's what happens when super energetic particles streaming from the sun slam into atoms like oxygen and nitrogen way up in our atmosphere. Those atoms get all excited, and when they calm back down, they release that extra energy as little flashes of light. Now imagine that happening billions and billions of times every single second. That's how you get those huge glowing curtains we see from the ground. Okay, and this is where the story takes a really interesting turn. Because the aurora isn't just a light show, it's actually the visible evidence of a massive transfer of energy from space down to Earth. And that transfer kicks off a chain reaction with some pretty big consequences far below those shimmering lights. And to really get it, we need to look at the two main players in this whole cosmic dance. Our sun, which is the relentless source of all this energy, and Earth's invisible force field, our silent protector. So on one side, you've got the sun, and it's constantly blasting out this stream of charged particles called the solar wind. Luckily for us, Earth has a magnetosphere. It's this amazing magnetic shield that deflects most of that solar wind, and it's what protects all life down here on the surface. But here's the thing, that shield isn't perfect. Sometimes, especially during these really intense solar storms, our magnetic shield just gets overloaded. And when that happens, it funnels enormous amounts of these energetic particles down towards the north and south poles. This absolute downpour of particles is what scientists call energetic particle precipitation, or EPP. And yep, this is what creates that dazzling aurora. But while we're all looking up at the pretty lights, those very same particles are kicking off a hidden chemical reaction far, far below. Right, because those raining particles, they don't just create light. They're actually the trigger, the thing that starts a really complex chemical cascade high up in our atmosphere. Okay, so this diagram might look a little complicated at first glance, but trust me, it's basically a map of that whole hidden process. It shows exactly how a storm on the sun can set off a chemical chain reaction right over our heads. So let's break it down into 4 key steps. First, the EPP particles pour into the upper atmosphere. Simple enough. Second, as they collide with all the air molecules, they create this family of highly reactive chemicals called odd nitrogen, or NOx for short. Third, during the polar winter, you've got these strong circular winds, the polar vortex, and they act like a giant atmospheric elevator, pulling this NOx downward into the stratosphere. And this is the crucial part. Step 4, once this NOx gets to the stratosphere, it starts destroying ozone. And it does it catalytically, which means a single NOx molecule can destroy thousands and thousands of ozone molecules over and over again. It's an incredibly efficient wrecking ball for the very layer that protects us from the sun's harmful UV radiation. Now, you would think this whole process would be pretty much the same at both poles, right? I mean, that makes sense. And that's exactly what scientists thought too. But when they actually looked at the data, they found a fascinating puzzle. And this slide just lays the mystery out perfectly. Just look at the graph on the left for the southern hemisphere. That red line, that's solar storm activity, and the black line is the amount of that ozone-destroying NOx. See how they basically move in perfect sync? More storms means more NOx. It's totally predictable. Now, look at the right, for the northern hemisphere. It's a total mess. The lines are just all over the place. There's no clear connection at all. This chart just hammers the point home, and it's kind of shocking, really. In the south, the correlation between solar activity and the NOx is 0.90. That's nearly a perfect 1-to-1 match. But in the north, it's just 0.06. Statistically, that's basically zero. No correlation at all. So what on earth is going on? Well, the answer seems to be that the northern hemisphere's atmosphere is just, well, it's more chaotic. You've got all these extra winds and atmospheric waves stirring things up, and these things can have just as much of an impact on pulling down that NOx as the solar storms themselves. It just makes the whole system incredibly difficult to predict. And look, this puzzle isn't just some academic curiosity for scientists to chew on. Understanding this process is absolutely critical because it directly affects the health of our planet's protective ozone layer. This slide shows a perfect and frankly kind of scary example from back in 2004. In the top graph, see that massive green spike? That's the amount of NOx that came pouring down after a major solar storm. Now, follow that timeline straight down to the graph right below it. See that huge dip in the blue and red lines? That's the ozone concentration plummeting at the exact same time. The connection is direct, it's undeniable. When NOx goes up, ozone goes way down. And we are not talking about small changes here. In that 2004 event, scientists measured a localized ozone reduction of up to 60%. 60%. That is a significant bite taken out of our planetary sunscreen, all triggered by a storm on the sun 93 million miles away. It's kind of mind-blowing when you think about it. And this really gets us to the heart of the problem for scientists today. A key research paper on this topic puts it bluntly, stating, there is a fundamental gap in our understanding. We simply don't have the full picture of how this NOx is created and moved around. We are missing a huge piece of the puzzle. So why is there a gap? Well, it's actually pretty simple. This entire chemical cascade, from the NOx creation all the way to its descent, it all happens during the complete and total darkness of the polar winter. And most of our satellite instruments, well, they need sunlight to make their measurements. So for months on end, this crucial process is happening completely in the dark, hidden from our view. Which leaves us with a final and pretty powerful question. Those beautiful auroras we all love to look at, they're really just a signpost pointing to this powerful, ozone-destroying process that's unfolding completely in the dark. So, to better predict its impact on our atmosphere, to really understand our planet's future, it seems we have no choice but to venture into that darkness and see what's truly going on.